Thank you. Okay. So I'm sorry if you're following along at home with the recordings. I just started. We did a little bit, not too much. So we did this. We figured out the revenue. We brought the cost into play. We subtracted the two, which makes sense. The amount of money you pull in minus the amount of money you got to put out. That's going to be the amount of money left over for you to play with. That's your profit. How far are we? I think we finished enough of this. Yes. Cool. Now we're going to get into some, if there's no other questions, we're going to get into kind of the next level of things. So let me get some white space here. I'm sorry. I think I have, sure, we'll use this. I can't remember. All right, now, so let's, maybe I should do this on the board. We'll see if I need to get up. What would I do here, of course?
Distributive property.
Yeah. So the 5x times x. And the 5x times -3. Okay. No big deal, right? We've done that before. Yeah. So what if I have a problem like this? Now some of you guys know what to do here. Do you guys, anyone know what the word is for this? Starts with the F. It's a 4-letter word, starts with F, that you can say in mixed company. Anybody know? It's F-O something. Foil. Okay. Now, to be really honest, what's funny is I brought that up, didn't I? And I hate it. It is stupid. Now, what do I hate about it? I don't hate the process that it's talking about. Do you guys know Mnemonic Devices? Anybody play music at all?
Yes.
Do you know about Face and Every Good Boy Does Fine?
Yeah, those are the notes on the clefs.
Yes, so Every Good Boy Does Fine. Those are the musical notes. I'm hoping I remember correctly, because
yeah, that's on the treble clef.
Yeah, and then Face, isn't that another one?
That's the bass clef.
Bass clef. Okay, so those are mnemonic devices that help you remember things when it's maybe difficult to remember them. Foil is dumb. We don't need now. So I want to show you. I'm going to do more work than I have to first, and then show you the shortcut, and then I'll see if some of you guys actually know this and just forgot the name of it. So see what I did with the thing here? Didn't I distribute it to both, right? Of course, right? So don't I have this thing sitting here? Wouldn't I just distribute it to both? What the hell would that look like? So it'd be 5x minus 2 times x plus 5x minus 2 times -3. I wrote that a little bit weird, but hopefully, do you guys see how that's the same thing I did up here? Then I take the 5x times x. And then I take the 5x times -3. Yes. Isn't that what we did? Of course, that's what we did. We just sort of did it in our head because there wasn't a lot going on. Well, here, there's a little bit more going on. I better write it for me. And then what can I do? What can I do on each one of these? What can I do here? What can I do right here? Come on.
Multiply by x.
Yeah. So I'll get 5x squared minus 2x. And then what do I get here? What's -3? Yes, sorry.
-15. And x. I forgot x. And +6.
All right, let me stop for a minute. Does everybody see those? All right, now just to get ahead of anybody who's like, well, what the hell are you doing, Jeff? We don't show this. We don't do this step. Notice what we do. I really want you guys to understand this. I don't need frickin' FOIL. FOIL is bullshit. I think I've made that point clear. I don't just have a 5x sitting out front. I have a 5x and a -2. So they each get a turn. 5x times x, bam. 5x times -3, bam. -2 times x, bam. -2 times -3, bam. Does that feel familiar to anyone? You might have forgot, but all right, even if it doesn't feel familiar, do you get the idea? I would call this repeated distribution. That would be my name for it. What am I doing? I'm distributing this, bam, bam, and then I'm distributing this, bam, bam. So when I have more than one thing sitting in front of a thing, they each get to distribute. They each get a turn. That's all that is. Now, what can I do? Am I done with this? Does anyone see anything I can do in this thing?
Combine
it's
my
gonna-
difference.
My God, overload.
5x2.
You guys are like, well, you like interaction.
Yeah.
Here we come.
Negative
Yeah,
17x
there we go.
plus 6.
Beautiful. Look at that. A thing of sheer beauty. All right. Now, I can't remember if I have a, here, let me let you guys try a problem and I'll take a look. I don't know if I have a handout up about this. I might. Let me clear this away. You guys ready? I'm going to clear this away. You guys try. Why are you going to change the color? It doesn't matter, John. You guys try this one. So multiply this out. All right, now I'm going to take a look here. Doobie squad. Oh shit, what is going on here? I can't see it. Oh man. Doobie squad. A doobie. What are you singing, Jeff? I don't know. Strangers in the night, exchanging their clothes. All right, let's see. I don't think I do. That's all right. Oh, well, donde? There you are. No, I don't. Okay, that's fine. All right. Good. Bum, 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 bum. All right, I'm going to color code this. So 4x gets a turn, right? 4x times 2x is 8x squared. 4x times 5, 20x. Then -3 gets a turn. -3 times 2x is -6x. -3 times 5 is -15. Okay, and then we get, of course, what do I get after that?
X squared plus 14x minus 15.
Sweet. Now, let me ask you this. Have I performed any math this semester in my head quickly? Have you noticed that? Have you seen that happen? Do you want me to show you something based on foiling? One little thing that I do in my head to make things easier? Is anyone curious about that, or you want to keep going?
Yes, it is.
All right, so watch this. What if I had to do 19 times 18? And again, this is nothing you ever have to do. I just want to show you. This is how I would do 19 times 18. Isn't 19 20 minus 1? Isn't 18 20 minus 2?
Yes.
Isn't 20 times 20 easy? 20 times negative 2. So I get 400 minus 60 plus 2. I get 342. So somebody double check that.
It's beautiful.
What? Sorry?
I said this is beautiful.
Oh yeah, isn't it?
I
Isn't it?
like it.
Yeah. Isn't that cool? All right. Well, I got one cool. That's all right. So yeah, you could do, so if I had to do 33 times 39, I could do 30 plus 3 and 40 minus 1. Try to make them nice and round, and then that's a little easier in my head to do, definitely, right? So that's just one tiny little thing you can do with this idea of foiling. Something else I want to show you. All right, so that's cool. That's cool. That's its own idea right there. You don't have to understand it. You don't have to ever use it, but there it is. Just a little thing. Let me show you something else. Oh, shit. Let me look at the chat. Weird. Okay, I accept that. Let me make some room here. I'm gonna erase all this. You guys ready? I'm gonna erase this right here because I want to talk about this. All right, here it goes. Chua. Oh, shit. Chua. Don't go too crazy, Jeff. I need a bigger eraser. Go away. All right. Can somebody tell me what is X in this? What is X? What is it? Do you know what it is? Is it 7? Is it negative?
It's a variable.
It's a variable. So what could it be?
Anything.
Anything. Somebody tell me, give me a number for X.
7.
7. All right. So if, now just stay with me. Again, this is extra shit. This is something you never, ever have to do. Ever. In fact, this is, well, we'll see. We'll see. This is not as interesting to me as the last thing I did, but it's still a little interesting. So if X is 7, what number is this? 4 times
4
25.
times 7 minus 3.
Yeah, so that'd be 28 minus 3, that's 25. And what number is this? It'll be 14 plus 5, it's 19, correct?
19. Yeah.
Now, if you throw that in your old calculator, what do you get? Or if you use the little trick we just learned, right? I would do 25 times 20 minus 1. See there? This would be 500 minus 25. I get 475. Is that what you guys, if you do that in calculator, is that what you get?
Yes.
I'll never know. Oh, yes, it is.
Yes.
Okay, good. Is everybody with me? Where'd 7 come from? Why 7, Jeff? Because that's the first number I heard. Why not 3? You can put a freaking 3 in there. You can make it anything, because what is X? Anything it wants to be. Anything you want it to be. Ooh. Okay. What is this? So what did we do here? What are we claiming about these two things with this work that we just did? What am I claiming about this and this? How are they related? These two things, how are they related?
That your answer would be the same?
They are the same. So if I throw in a 7 in here, let's see, I'm supposed to get this. It better frickin' be that, or else this whole thing is shit and we can all leave. All right. So if you put that in your calculator, what do you get? Let's see.
It's the same.
It's the same. Okay. You can double check. All right. So that's not as interesting as it's not quite as interesting, but it's just when we do this, how many numbers are we actually multiplying when we multiply those? An infinite number of numbers, because X can be anything. I think that's a little bit neat. Okay. I don't know if you guys are with me. So what's the only thing you have to really know from what we just did? Just this. Everything else was extra. All right, so let me clear this away. Clear. All right. Here, try this one. Do this real quick. All right, FOIL that out or multiply that out, distribute that out, whatever you're gonna call it. Wednesday, that's right. Yeah, all right. I'm going to slowly start to catch up with you guys. 5x gets his turn. And 7 gets his turn. Does that look familiar? Does that look what you got? And then
Yep.
what happens? What happens next?
Combine the 35 X's.
What do you get then?
Minus 49.
Negative 49.
Yeah, these cancel each other, right? Right. That's a little bit interesting, right? That's a little tiny bit interesting. Okay. Anyway, so this is actually something called a. Let's see if you guys can understand. Why would a math person call this a difference of squares? Why would we call that a difference of squares? Is it a difference? Difference would mean subtraction. So is it a subtraction problem? Yes. Are the terms involved squares? Yes. 25 is a square, 49 is a square, x square is a square, right? So that makes sense. We call that a difference of squares. And it always happens when you have the same things in here, different signs. That's what would make the middle term cancel, because it'd be the same, just opposite signs. So that will always result in a difference of squares. It's very neat. Or, somewhat neat. Is that mildly interesting? Just above boring. Okay, I can live with that. So let me clear all this away. Here we go. Clear. All right. Blah 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 blah. So here's where they talk about all kinds of shit. They slowly catch up to what we just did. Blah 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 blah. Okay. So here's the neat thing. This is what we call the factored form. It kind of makes sense. So like, can somebody tell me, how do you factor 15? How do you factor 15?
3 and 5.
Yeah, 3 times 5, right?
Two numbers that go into 15.
Yeah, so 3 times 5 is the factored form of 15. So this is the factored form. When I multiply it out, I'm just going to jump to the answer. That's not factored. So this is the factored form, and this is the simplified form. I don't know why they call it expanded. It's the simplified form. That, who cares? Those are technical terms. But you guys remember I showed you the next section is factoring? So the next section is going to be where I give you something like this. and you work out what it would have come from. So we do everything we just did, we're going to do it backwards. And of course, that's always more difficult. Not difficult, just more difficult. Does that make sense? I don't know. All right. So let's finish this up before we get into factoring. I'm going to clear all this away. Clear. All right. Let's see, blah, blah, blah. Oh, okay. So here's a few little things. All right. Can you guys do number 1 for me right here? Go ahead and do number 1 for me right there. Please realize, am I multiplying anything in number 1? What's the main operation in number 1?
Addition.
Addition. So what's the main idea in number 1? I want to collect all of my, I want to combine everything that is what?
Like terms.
Like terms. Cool. Do it. Do it. I just want to, well, okay, we'll talk about it in a minute.
It's gonna be 5x2 x2 negative 5.
Yeah, so we have 3x squared. What's understood to be right there? What's understood to be right here? What's in front of that?
Parentheses.
A 1.
No.
1.
Yeah, 1. Yeah. So will that 1 change anything in here if I distribute it? No. So I don't have to worry about it. So 3x squared. All right, let me get rid of all that crap. Okay. So what I do is like this: 3x squared plus 2x squared is 5x squared. 3x minus 3x canceled. These are
They cancel each other.
That's right. And then 5 minus 10.
Negative 5.
Excellent. Excellent. Let the math flow through you. All right. Now, what's different about number 2? There's a big difference in number 2.
Subtraction.
Yeah, subtraction, baby. So there's still that understood 1 here. What do I do when there's a number sitting out in front of stuff in the parentheses? Yes?
Yes.
It
we change
changes
the
it
signs.
to
Good. So up here, why didn't we do that? Well, we did. It just didn't change anything. It's just a 1. It's not going to change anything. Who gives a shit? Any other number out there besides 1 will change the stuff. So my suggestion to you is to rewrite everything. This stays the same because it just has a 1 out front. What does this become?
Negative x2 plus 4x 2x. I'm sorry.
2x.
2x and negative 7.
All right. And then you do just like we did on number 1, right? All right, so this should be not too bad. A few of us still have trouble with like terms every now and again. But to be like terms, you have to have the same letter and the same amount of each letter. So I can put together my terms that have x squared. I can put together my terms that have x. It's really just consolidating. Why would somebody go, oh yeah, I got 5x squared over there, and this guy just took one of my x squared? Just say you have 4x squares. I don't need a rundown. How many x squares we got? Well, we had 5, and this guy came along and he took one. Just tell me we have 4. Just tell me you got 4, right? You guys with me? So that's 4x squared. Put this shit together. And they got 3 x's over there and 2 x's. No. How many x's do we have? I can't make a 2.
5.
That's a problem for my job. Yeah, 5, right? So 3x and 2x. 5x. And then of course, how many numbers we got?
-5.
Minus 5.
Minus 5. We owe 5 some to somebody. There we go. Schlabang. So of course, what would you do on number 3 first?
Distribute the 3 and distribute the 2.
Good. And then bait your like terms together. You got to distribute first because then stuff is free to move around and go with its like terms. All right, we won't do that. Let me see. Let me clear all this away. Yeah. All right. Blah, 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 blah. Blah, 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 blah. Let me see. Anything new here? Book? No. Blah, blah. Blah, 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 blah. Oh, well, this is not new, but let me see. Here, let me throw at you. Here, let me use this right here. Let me see what you guys think about this. All right. Try to do this. What am I drinking? I don't know. Oh yeah, it's my favorite. Look at that photograph. Do you guys understand that this is not different at all? There's just one more term to worry about. So the 2x gets a turn, right? What's 2x times 4x squared?
8x cubed.
8x cubed. And then somebody else tell me what's 2x times negative 5x.
-10x2.
I like it. And of course, I'll do this one. This is the hardest one. 2x times 1. Oh, I think it's 2x. Okay. And now 3 gets his turn. And look what I'm gonna, well, let's see. I'm gonna do it. What's 3 times 4x squared?
12x squared.
Look what I'm gonna do. I'm gonna kind of line it up with the like terms. See there? You can if you want to. You don't have to. And what's 3 times negative 5x?
Negative 15x.
And then 3 times 1. Oh my goodness. All right. So now I can just get my like terms. You got 8x cubed. 12 minus 10 is 2x squared. Negative 15 plus 2 is 13, negative 13. And then I got my plus 3 out there at the end. Kablamo. 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 Bum, 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 bum. Got sunshine. All right. So here, real quick. Foil comes from it doesn't matter. First, outer, inner, last. That's where foil comes from. If you never heard that, forget it. Because wouldn't that just die here? Wouldn't foil just completely die here? Wouldn't you need like an M? It'd be no, I don't know if you guys understand what I'm saying. So that's dumb. That's why foil is dumb. It's better to teach repeated distribution because then it doesn't matter how big either one of these gets, right? No matter how big these get, I just take one, put it through, take the next one, put it through, take the next one, put it through, and then get my like terms again. I don't need to call it something. Okay, all right. So let me clear this away. I know. A lot of algebra today. It's too bad. Here we go. Clear. Let's see, what else do I want to talk about? So they talk about that issue here. Who cares? It's not bad, blah, blah, blah. Oh, let me do one more that they don't do. Ha 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 ha. Here we go. What do you guys think about this? And then I think maybe we'll move on. What do you guys think about this? Oh, shit. Oh, shit. Try to do this. Uh-oh, is there a little person? I gotta watch my language. There's a little person over there.
It's gonna be 4x square plus 25.
No, good try. Nope,
Okay.
definitely not. Let me help you guys out a little bit. If I ask you to do this by hand, what would you write down? If I ask you to do 23 squared by hand, what would you write down?
23 times 23.
You'd write 23 twice and then multiply, correct?
Yeah.
All right. And what is 2x minus 5? What is it? What is 2x minus 5? What is it? That's a weird question. I don't care.
2x minus 5.
No, what is it? What does it represent?
Yeah, it's gonna be 2x minus 5.
Stop. I don't care. Oh, I know where you're going. Answer my question first. What is 2x minus 5? What's x?
It's a variable,
Which represents what?
a number.
A number. Yay. So if I put a number in for x, what does 2x minus 5 become?
An equation.
A number.
Oh, yeah.
So if I pick a number for x, doesn't 2x minus 5 itself become a number? So this is just a number. This is all this is a number. How will this act then? The same way any number would act. This is something that students don't understand. And I haven't said this a lot to you guys because we actually haven't done a lot of pure algebra this semester. It's every now and again, but everything we do with variables is based on what we do with numbers because variables are numbers. That's it. So if I had 23 squared, I'd write it twice. So I have 2x minus 5 squared, so I'm going to write it twice. Okay. And then I can multiply it. So if I don't write it out twice, how the hell am I going to multiply it? Right? Is 23 squared equal to 49? Do you see where I got that from? Is 23 squared 49? How did I get that? I squared 2 and I squared 3. But that's bullshit, right? That's bullshit. I like it. So I have to write it twice and then multiply it out if I have to do it by hand. All right, well, I got to do this by hand because my calculator can't do this for me. Damn it. Some calculators can, though. They're a little expensive, but there are calculators out there that would do that for you. Where can you get one? I'm not going to tell you. Which one is it? I'm not going to tell you. Anyway, so what do you guys get here? You get
4x squared
x squared
minus 10x minus 10x plus 25.
You get 4x squared minus 20x plus 25. Kablam. Okay. Neato. Okay, let me move on. I'm going to clear all this away. Ready? Oh, and here's the homework. Yay. So of course they're going to pretty much mimic the bath beads problem. So if you need help, you can always go back to that whole thing we did together. So this whole thing is about, they give you the price function. They want to know the revenue function. They give you the cost function. Then you got to make the profit function. Right. And I know this feels a little bit like it's become business class, and I'm sorry. I think I've expressed to you my opinions about business stuff. But still, this is mostly math. So that's okay. I can deal with it. Blah, blah, blah. So this is the applications for this. So what I want to do today, we're going to do a little bit of this. I want to get a little bit into the next section, which is everybody's favorite, the F word, fudge. No, the F word is factor, right? Okay. So what I have is a neat handout. Let's see if you guys agree with me. So if you go to Canvas right now, if you're not able to, don't worry. We're just going to do a little bit from this handout. Under Unit 4, you'll find factoring motivation. Has anyone ever acted before? Anyone ever done anything with theater?
In middle school.
Yeah. I became a thespian in high school. I was in the theater there. I actually never acted. I was always behind the stage setting up the stuff. Anyway, so my motivation. So what's the motivation behind what we do? So we're going to do a couple of things off of here, and then we'll continue it. We're going to continue it tomorrow. Let me see. I need some more, whatever this mystery liquid. That'll make things better. All right. So go ahead. If you can't get this, don't worry. We're going to do a little bit of this together. I'm going to open this up. Well, screw it. I'll just do it right here. It's fine. No, maybe I should open it up a different way. Sorry, guys. Hold on. I'm thinking on the fly here. That's always exciting for me. Do strangers in the night. Be quiet, Jeff. Shit. What would I call this thing? Factoring handout. That makes sense. Is that the one? No, it's not. You suck. Go away. All right. Somewhere. Sorry, guys. Hold on. There it is. There it is. Yes, sweet. Is this the same thing? Blah, 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 blah. Yes, it is. Okay. All right. Sorry, everybody. Hold on. Oh, shit. There it is. All right. So this is going to seem really strange. This is going to seem really strange, really unconnected. I've got a number puzzle for you. Okay. I've got a number puzzle for you. Let me come in. Let me do a couple examples of this before we do that. Where do you want to do this, Jeff? Yeah, right there. Let's say I have two numbers. If I have two numbers, and I know that they add to be, 11, and they multiply to be 30. So I know that I have two numbers and they add to be 11, but when I multiply them, I get 30. Can you figure out what those two numbers are? This seems disconnected.
Yeah, it's 5 and 6.
Yeah, does everybody see that?
No.
5 and 6. So what's one way you could do that? Where you can say, well, let's see,
It's,
7 plus 4 is 11, but that's 28. Well, shit. 6 plus 5 is 11, and that is 30. Yay! Right. So you can kind of see, or you could do the other way. You could say, well, 3 times 10 is 30, but 3 plus 10 is 13.
Yeah, the X thing. I don't know.
Oh yeah. You've done this, the master product, or the you put this and you put that. Yeah, I actually don't do that, but for some reason students think it's magic. But if the magic works, then I'm not gonna, that's fine with me. A little placebo effect. What if two numbers? Does everybody understand what just happened with this? 5 and 6 are the numbers because they add to be 11 and they multiply to be 30, right? All right. I know this seems a little disconnected, but this is related to what we have to consider when we're going to try to factor something. Trish?
Is there a better way than just guessing?
Not really. Yeah, I mean, you're constrained, which doesn't mean you just guess like, let me say 20 and 50. Well, you would never guess 20 and 50 because that doesn't do either one of these things. So you start with, you either say, okay, what adds to be 11? 7 and 4 does, but they multiply to be 28. Ah, shit. And then you kind of like, it's sort of like a Price is Right game then. Higher, lower, higher, right? There is no way to make that generally quicker. there are ways to make that process quicker within itself. All right. So what if I had two numbers? Let's see if you guys get this one. They add to, you can do it, Jeff. They add to 3 and they multiply to be, what, Jeff? I don't know. -40. Yeah. So what do I know about the two numbers? Are they the same sign? Are they
No.
both positive? Are they both negative? Well, what's true about them? What has to be true about them?
Have to add to 3 and multiply to -40. So one of them has to be negative.
Good. They have to be different signs, because if they were the same sign, they would multiply to be positive.
Yeah.
So now hopefully that kind of narrows things down. So you could either start with, all right, list some things that multiply to be -40, like 4 times 10. But if I make either one of those negative, does it make 3 when I add them? No, I only get some kind of 6 when I add these. Do you guys see what I'm doing?
So it'd be a positive. Do you want the answer?
Sure.
Okay, it's a +8 and a -5.
Yeah, so 8 times 5 is 40. And if I make the 5 negative, what do I get when I add those together?
3.
3. All right, let me stop for a minute. You guys get a feel for this? And I appreciate Trisha's question. So it's not completely random guessing. We guess something based on one of these conditions, and then we check to see if it makes the other thing true. So we can either start with 40. Give me two numbers that multiply 40, 4 and 10. Can they make 3 if you make one of them negative? No, they'll only make 6 or -6. And then you kind of go through what multiplies to be 40, 2 and 20. That won't work. Shit. 1 and 40. That won't work. Shit. 8 and 5. Oh, okay, that'll work. There's a 3 apart, right? So that would work. Or you could start with, like, what adds to be 3? 10 and -7, but they multiply to be 70, don't they? -70. 9 and -6 make 3, don't they? But they multiply to be -54. 8 and -5. Oh, there you go. Are you guys starting to understand? So yes, it sucks a little bit because you do have to play around with the numbers. Make one of the conditions true and then check to see if the other condition also is true, right? That's what I did here. 10 minus 7 is 3. Check. 10 times -7 is -70. Oh, shit. Try again. And again, you can dislike it some, I understand, but I want you to understand it. Do you guys understand? This is a number puzzle, right? So let's look at this handout. I'm going to erase all this scribble shit. You ready? Here it goes. God, okay. So let's come up to this. Don't say anything. Don't say anything. Just find two numbers and multiply to 24 and add to 11. Don't say anything. All right, who's got it?
It's gonna be 3 and 8.
Yeah, 3 and 8 do both things. So again, I could have started with, all right, what adds to be 11? 5 and 6, but that makes 30 when I multiply. Shit. 4 and 7, but that makes 28 when I multiply. Shit, but I'm getting closer. And then of course I get to 3 and 8. All good, right? Or I could start with 24. 2 times 12 is 24, but they add to be 14. Damn. 3 times 8. Yay. All right. So it's yes. It is based on guessing, but not random guessing. It's guessing based on what they tell me about the numbers. All right, now try part B. And again, don't say anything yet. Try to do part B. What time is it? I want to, okay, all right. Let me give you a little hint. Again, if they multiply to be negative, the numbers have to be different signs, correct? If
Yes.
I combine two numbers with different signs, isn't that more like subtracting?
Yes.
Yeah, if I combine 5 and -7, I get -2, which is 7 minus 5 with a -1. So I need two numbers that are 6 apart, because they're going to be opposite signs. When they add to 6, that means they're actually 6 apart, and they multiply to -40.
Yes, I have it.
Okay, what do you got?
10 and minus 4.
10 and -4, that's right. So 10 times -4 is -40, and 10 minus 4 is 6. So here's to give you, add to 6. So let's see, what's 6 apart? 3 and 9 are 6 apart. Right, so if I make 3 negative, that's 6 if I add them, but they multiply to be 27. Shit. Then I go -4 and 10, those are 6 apart, they make 6, and they multiply to be -4. Yay! Some of you guys are going to be better at this than others. It's just one of those things. It's sort of like, I was not the best painter in the world. I'm actually better than I thought I would be, but I'm still not the best painter in the world. And somebody sitting next to me could be the freaking amazing and barely have to think about it. And bam, there's a painting. And I'm like, tree. No, it's a telephone pole now. You know, it's a rock now because I can't. All right. Sorry. What about part C? Notice they multiply to be negative. So we know what that means.
Can I say?
Not yet.
Okay.
Thank you, though. And they add to be -1. I want you to realize what that means. If they're opposite signs, they would subtract when I combine them. So I need two numbers that are 1 apart that multiply to be 56. All right, go ahead and tell me.
-8 and 7.
Are you getting outside help? I can't. That little person, if they're helping you, I don't know what to do. Okay, now. I don't know if you guys are starting to get a better feel for this. And again, you can hate it all you want as long as you understand it. Now, I want to give you a little taste as to what this has to do with factoring. Can take a quick minute. Go ahead and multiply it out. Take a quick minute and multiply this one out right here. Go ahead and multiply this guy out. Oh man, did I find this? It doesn't matter, Jeff. It's fine. All right, this should be pretty quick, I think, right? So I'm going to start to catch up to you guys. So you get x squared plus 5x plus 4x plus 20. So I get x squared plus 9x plus 20. Look at these two numbers right there. Are those two numbers that add to be 9?
Yes.
4 and 5. Do they add to be 9? Yes. What do they multiply to be?
20.
20.
Mhm.
4 and 5 are two numbers that add to be 9 and multiply to be 20. Interesting. All right. And if we do this, x squared plus 8x, I'm just going to do this a little bit quickly. X squared plus 8x plus 2x plus 16. X squared plus 10x plus 16. Good Lord, what happened to you? 8, 8 and 2 are two numbers that add to be 10 and multiply to be 16, correct? All right, so I'm gonna forget about those for a minute. We'll do those next time, but I want to show you real quick. So if I gave you this x squared plus 10x plus 21. I really want
Can I
this.
say?
Not yet, hold on.
Okay,
X squared would have come from x times x. Is that cool? That's easy. The hard part, or not so hard, but the more difficult part, is what numbers go here and here. Well, what do those two numbers have to do, like we just saw happen here? These two numbers, here and here, have to add to be 10. Yes, yes, yes. Because
Yes.
that's where the middle term always comes from. It comes from those two numbers adding, and they have to multiply to 21.
Mhm.
So go ahead and tell me.
7 and 3.
So that is this whole process, this number puzzle, two numbers that add to be this and multiply to be that. That is a key skill to have if you want to factor something. And here, last thing I'll show you, then we'll call it a day. I know, trust me, we're going to do more on this. Don't worry. But I want to show you real quick. Remind me again, what is x?
It's a number.
A number, any number. Give me a number, somebody.
4.
4, I love it. If x is 4, why 4? Because he said 4. Nobody else said anything. It could have been anything, right? If x is 4, can somebody tell me what this number is? Wouldn't this be 16, right? If x is 4?
Yes.
16 plus 40, that's 56, plus 21, isn't that 77? Are you guys understanding? If x is 4, this number is 77. If x is 4, what is this number? If x is 4, what is this? If x is 4,
11.
11. And if x is 4, what is this number?
7.
7. So is one way to factor 77 11 times 7?
Yes.
Yes. All right, sorry. So when we factor an expression like this, you could actually check it by making x something and making sure that it makes sense, because it has to make sense. We just factored an infinite number of numbers. I want you to understand that. When you factor this to make it become this, you factored an infinite number of numbers. So if somebody says to you, what'd you do today? Well, before 11 a.m., I factored an infinite number of numbers. What did you do? Lazy, blah, blah, blah. No, sorry, don't say that. All right, I know. We'll do more of this. We'll do more of this. Let me see. Oh, let me see if you guys can do one by, let me see if you guys can do one. Let's see. I'm going to clear all this away. You guys ready for that? We're going to do one more here and then we'll call it a day. All right, this is all gonna go away. Here. So try this one real quick. Try part A. So you can pretty much always do this. This is pretty much, you know, this is true to make x squared. So all you got to do is figure out what the two numbers are. Don't say anything. Can somebody tell me what do the two numbers have to do? They have to add to what? What do they have to add to be?
Add to be 8,
8,
multiply to
Multiply.
be 12.
12. And that's the two numbers that will make this complete. So what are those two numbers? Who's got those? What adds to 8 multiplies be 12?
6 and 2.
And then let's check this real quick. So that's the answer. That is the answer. That is factored now. But let's check it. X squared plus 2x plus 6x plus 12. And of course it works because we made 2 and 6 make 8 when you add them, and they make 12 when you multiply them. So of course that makes it work. I don't know how you guys feel at all, but it's okay. All right, that's enough for today. We've done a lot today, so that's plenty. So we'll continue with factoring tomorrow. Don't forget the quiz should be open now, I think. So if you want to start it now, you can. Oh, shit. Somebody just left, but I'll send an email out. For the quiz, you can write down, oh, here. I didn't put this on the quiz, but you can write down this formula here. Because of course you normally can't use notes, you can't use the book, you can't use anything when you're doing a quiz like normal quizzes in college. But I will let you write down this equation for the error. All right, that's enough. So you guys, the quiz I gave you until tomorrow night to finish it. So you have until tomorrow night to start it and finish it. Okay.
What time tomorrow night?
Let's see. Let's find out together. I'm going to clear all this away. You ready? All right. All right. Where are you, quiz? This quiz is unpublished. Oh, wait, that's the wrong quiz. Let me become a student. Let's make it easier. There we go, quiz 6. Here we go.
11.
Yeah, 11 p.m.
All right. Thank you, Professor.
You're welcome. Everybody good? Anybody have any questions? All right, I'm headed out.